Hello everyone, good evening. So here we should start from question number 59 onwards. So here, first we'll write what is given. It is told that ABCD is a quadrilateral. ABCD is a quadrilateral in which so this is actually an extension. This point is actually Q. This point is Q. Okay. So ABCD is a quadrilateral in which AB is parallel to DC and P is the midpoint of BC. P is the midpoint of BC. Then AP and DC, when produced, AP and DC when produced meet at Q. Meet at Q. AP and DC when produced meet at Q. So we have to prove that. AB equals to CQ. AB equals to CQ. The second is to prove that DQ is equal to DC plus AB. DQ is equal to DC plus AB. So the proof is that it is a quadrilateral. Here we can see that AB is parallel to DC, which is given. So we can also say that AB is parallel to DQ also, since DQ is simply the extension of DC. Therefore, we can say that angle BAB, that is equal to angle DQA. I can say angle BAQ, that is equal to angle DQA. Since why? Since they are alternate interior angles are equal. Since alternate interior angles are equal, since we can say that AB is parallel to DQ and AQ is the transversal. AQ is the transversal. Is the transversal. So now we can say that in triangle ABP and triangle QCP, angle APB, that is equal to angle APB, that is equal to angle QPC, Since why? Since vertically opposite angles are equal. Vertically opposite angles are equal. And you can see that angle BAP and angle BAP, that is equal to angle CQP. Angle CQP. Since why you have shown that angle BAQ is equal to angle DQA, it also means that angle BAP, that will be equal to angle CQP. Same thing, since DQA is same as CQP. Angle DQA is same as angle CQP. So angle BAP is equal to angle CQP, since it is proved earlier, or I can say proved above. So we have shown that two angles and two angles are equal, and it is also told that P is the midpoint of BC. P is the midpoint of BC. It means PP is equal to CP, and we can also say that BP is equal to CP, since it is given. It is given that P is the midpoint of BC. So therefore, we have shown that two angles and one non-included side are equal in these two triangles. So therefore, I can say that triangle ABP, that is congruent to triangle QCP, QCP by AAS rule of congruency. The AAS rule of congruency. So I can say that AB is equal to CQ. AB is equal to CQ by CPCT. And also we can say that we can see that that DQ is equal to DC plus CQ. DQ is equal to DC plus CQ. And CQ we have shown is equal to AB. So we can say that DQ is equal to DC plus AB. So hence we have shown that AB is equal to CQ also, and DQ is equal to DC plus AB also. So hence and here it is told in the given figure, ABCD is a square and P is a point inside it, such that PB is equal to PD. Prove that CPA is a line. CPA is a straight line. So now it is given that ABCD is a square. ABCD is a square and P is a point. Is a point inside it. Is a point inside it, such that PB that is equal to PD. So we have to prove that CPA is a straight line. CPA is a straight line. So obviously CPA line we have to draw. Then the proof is that in triangle, we will say that in triangle APD and triangle APB, AP is common side. AP is common side, and AD is equal to AB, obviously, since ABCD is a square, it is given. Since ABCD is a square, so all the sides are equal, and you can see that PD is equal to PB, which is given. So therefore, I can say that triangle APD is congruent to triangle APB, which is by side, which is by SSS rule of congruency. Since all the three sides are equal in these two triangles. So by SSS rule of congruency, these two triangles are congruent. So therefore, we can say that angle APD that is equal to angle APB by CPCT. And similarly we can take in triangle CDP and triangle CPP. You can see that CP is common side. CP is the common side, and CD is equal to CB, since ABCD is a square. ABCD is a square, and PD is equal to PB, which is given. As PD is equal to PB, which is given. So therefore, we can say that triangle CDP is congruent to triangle CBP. Triangle CDP is congruent to triangle CDP by side, since all the three sides in these two triangles are equal. all the three sides in these two triangles are equal. All the three. So by SSS rule of congruency, the SSS rule of congruency, these two triangles are congruent. So therefore, we can say that angle CPD. So angle CPD, that is equal to angles CPD and CPB by CPCD. Now we can see that now angle, so the sum of these four angles should be 360 degrees. So you can say that angle CPD plus angle CPB, CPD plus CPB plus APD plus APB plus angle APB plus angle APB, APD, APB plus APD. So sum of all these four angles should be 360 degrees. Since y about a point, the sum of all the four angles about any point, that should be equal to 360 only. So now CPD and CPB is same, so I can say it is twice of so there was some connection problem in the Wi-Fi. Some connection issues were there in the Wi-Fi. So here it is all that. So we can say that it is twice of angle CPD plus angle since all the sum of the angles about this point P will be equal to 360 degree, and it is also proved that angle CPD equal to angle CPB. We have also shown that angle APD, that is equal to angle APB. So I can say that this is twice of angle CPD plus twice of angle APD, since APB and APD are equal. twice of angle APD, that is equal to 360, which means that twice of angle CPD plus angle APD, that is equal to 360. Now angle CPD plus angle APD, that is equal to angle APC. Therefore, twice of angle APC, that is equal to 360 degree. So therefore, I can say angle APC, that is equal to 180 degree. So angle APC is 180 degree. So it means that CPA is a straight line. So hence I can say CPA is a straight line. So hence proof. When A is stored in the game figure 61, O is the point in the interior of the square ABCD such that triangle OAB is an equilateral triangle. So that triangle OCD is an isosceles triangle. So it is given that O is a point in the interior. O is a point in the interior of a square ABCD such that triangle OAB is equilateral. Equilateral. So we have to prove that. Triangle OCD is isosceles. Triangle OCD is isosceles. So the proof is proof is given as in triangle OAB, angle OAB equals to angle OBA. Angle OBA, that is equal to 60 degree. Since triangle AOD is equilateral, so each angle is 60 degree. So each angle is 60 degree. And angle DAB, that is equal to angle CBA. Angle DAB is equal to angle CBA is equal to 90 degree. Since why? Since ABCD is a square and each interior angle in a square is a right angle. Each angle in a square is a right angle. So ABCD is a square which is given. So therefore we can say that angle OAT, that is equal to angle OCD, which is equal to 90 degree minus 60 degree. That will be equal to 30 degree. Since we can say that since here we see that angle OA plus angle OA, that is equal to AAB angle OB plus angle OBA, that is equal to angle CBA. And OAD is equal to OCB, that is equal to 30 degree. So now you can say that in triangle OAD, triangle OBC, angle OAD is equal to angle OCB. angle OAD equal to OBC. It's not OCD, it will be OBC. That is equal to, so angle OAD equals angle OBC. Since it is proved above, and OA equals to OB. OA equals to triangle OAB is equilateral. So all the sides are equal, and OD is equal to, or AD is equal to BC. AD equals to BC. Since these are the two sides of the square, ABCD is a square. ABCD is a square. So therefore, here in these two triangles, you can see that two sides and the included angle are equal. Two sides are equal and the included angle are also equal. So I can say that triangle OAD is congruent to triangle OBC by SAS rule of congruency. SAS rule of congruency. So I can say that. OD is equal to AC. You can say that OD is equal to AC. I can say that OD is equal to AC. Right? Hence, you can say that hence in triangle OCD, OC is equal to OD. So triangle OCD is isosceles since two sides are equal. So triangle OCD is isosceles. Please ask. Then we can work. So now it is given that in triangle ABC, D is the midpoint of BC. If DL is perpendicular to AB and DM is perpendicular to AC, such that DL is that DL is equal to DM. Prove that it is equal to AC. So it is given that in triangle ABC, D is the midpoint of BC. D is the midpoint of BC. And DL is perpendicular to AB and DM is perpendicular to AC. Says that DL is equal to DM. We have to prove that AB is equal to AC. Prove that AB is equal to AC. How to prove? The proof is that in this triangle BDL. Here this is C. This is the point C actually. This point C here. So I can say that in triangle BDL, and triangle CBL, PL is equal to DM, which is given, and angle DLB, that is equal to angle DMC, which is equal to 90 degree, which is given. Since why DL is perpendicular to AB and DM is perpendicular to AC. So now BD is equal to CD. Since it is given that D is the midpoint of BC. So the height in these two right angle triangles, the hypotenuse and one side are equal. So therefore I can say that triangle BDL is congruent to triangle CDM by RHS rule of congruency. RHS rule of congruency. So therefore I can say that angle DBL, that is equal to angle DCF by CBCT. So therefore we can also say, since DBL and angle B is the same and DCM and angle C is the same, so I can say angle B equal to angle C. So now I can say, so now in triangle ABC, angle B is equal to angle C. This proved above. Angle B is equal to angle C. And so I can say that AC equals to AB. Since we can say that the sides opposite to the equal angles of a triangle are also equal. Since the sides opposite to the equal angles, of an isosceles triangle are also equal. So hence we then in question number 63, it's told that the lines joining the midpoints M and N of parallel sides AB and DC, respectively, of a trapezium DCT is perpendicular to both the sides AB and DC. Prove that AD equal to BC. First, we will write it is given. We can draw the figure first. Figure will be somewhat like this. This is CD. So the midpoint of AB is N. The midpoint of DC is N. The line segments joining the midpoints M and N. So here AB is parallel to DC, and we have to show that AD equal to BC. And this line segment is perpendicular to both the sides M and N. And this is equal to AM equal to BM and BN equal to CM. So first we will write what is given. Given is in trapezium ABCD, M and N are respectively the midpoints of AB and CD. AB and CD, where AB is parallel to CD. And the line MN is perpendicular to AB also, and MN is perpendicular to CD also. Then we have to prove we have to prove that AD equal to BC. How to prove? So now we can join AN, and BN. So here, these two triangles, so these two triangles are obviously congruent. First, we have to write the construction. Construction is the line segments AM and BN are drawn. Line segments AN and BN are drawn. Then we will write the proof. So the proof is that in triangle AMN and triangle BNN, in triangle AMN and triangle BMN, angle AMN that is equal to angle BMN, AMN equal to BMN, it is equal to 90 degree, which is given. Since why? It is given that AMN is perpendicular to AB and MN is the common side. MN is the common side. MN is the common side. And AM equals to BM, since it is given that M is the midpoint of AB. So therefore, we can say that triangle AMN is congruent to triangle BMN. By write it in the next page. So therefore, triangle AMN is congruent to triangle BMN. How? By SAS rule of congruency. By SAS rule of congruency. So we can say that angle MNA, that is equal to angle MNB, CBCT. The reason is CBCT, and also AN is equal to BN. AN is equal to BN, right? CBCT. So now you can say that, angle ANM plus angle AND, angle ANM plus angle ANB, that is equal to angle BNM is equal to angle BNM plus angle BNC plus angle BNC, that is equal to 90 degree. Since why? Since both are, since we can say that since angle M and D, since angle M and D is equal to angle MNC, is equal to angle M angle MNC, which is equal to 90 degree. Since MN is perpendicular to DC, which is given. The MN is perpendicular to CD, we should tell here. Should not be parallel. MN is perpendicular to CD. And AB is parallel to CD. So therefore we can see that now MNA and MNB, they are same. So therefore I can say angle AND that will be equal to angle ENC. angle ANT is equal to angle BNC. So now we can say that in triangle AND, triangle AND and triangle BNC, we have angle AND equals to angle BNC, which is proved above. And angle AND is equal to BNC, and AN equals to BN, and AN equals to BN. This is also proved above. And DN is equal to CN, and DN is equal to CN, which is given. That's why N is the midpoint of CD. So therefore, I can say triangle AND is also congruent to triangle BNC by SAS rule. Since why these triangles are also equal. Since why the two sides and the included angle of these two triangles are equal. So therefore, I can say triangle AND is congruent to triangle BNC by SAS rule of congruency. If SAS rule of congruency. So So I can say that AD equals to BC, right? CPC. That's good. So hope all of you understood the solutions of all these questions till question number 63. Any doubts that you have, please write that in the comments. We shall obviously clarify them. So thank you everyone.